Good morning, students. In continuation to yesterday's topic, that is quantum numbers. Today I am going to teach spin quantum number. Altogether we have 4 quantum numbers. First one, principal quantum number. Second, azimuthal quantum number. Third, magnetic quantum number. Up to magnetic quantum number I taught. Today let us see spin quantum number. Since electrons are continuously spinning in the atom, therefore it is also known as electron spin quantum number. This is the 4th quantum number. So 4th one is spin quantum number. Now let us see what does this quantum number speaks about. What are its values? Because we have values for principal quantum number like 1, 2, 3, 4, etc. Right? For magnetic quantum number also we have the values. Now let us see the spin quantum number. What are the values given and what does this quantum number speaks about? This quantum number mainly speaks about the spin of the electron in the atom. How it spins. There are 2 types of spins exhibited by electron. One type of spin is clockwise spin. Means the direction in which the hand of our wristwatch spins, that is called clockwise spin. Number 2, quite opposite to that direction, when electron spins, then it is said to be anti-clockwise spin. So in this way here, spin quantum number speaks about the spin of the electron in 2 directions. One is clockwise spin of the electron. This is symbolically represented by sign. It is indicated by the value plus half. This plus sign shows that electron is spinning in clockwise direction. And second type of spin is anti-clockwise spin of the electron. This is indicated by minus half. The plus half means clockwise spin of the electron, minus half means anti-clockwise spin of the electron. Here, when electron is spinning in clockwise direction in this way, and when it has anti-clockwise spin in this way. So it leads to confusion sometimes that when the electrons are spinning in clockwise and anti-clockwise direction, there can be a chance for bombarding each other, that is hitting each other. Here they don't hit each other because if one electron is spinning in this direction, the other electron will be spinning in this direction. Since it is 3-dimensional, that is orbital. Right? So there is no question of bombarding each other. So electrons will not collide each other. That is the point. So that's about spin quantum number. Now we will see the orbitals present in different shells. Let us see. How many orbitals are there in n is equal to 3? What are they? So here the relationship between principal quantum number and the number of orbitals means magnetic quantum number. They are correlated. So here number of orbitals present in any principal quantum number can be calculated by the formula n square. N for principal quantum number or shell number. So shell number is 3 and number of orbitals means n square, that is 3 into 3. 9 orbitals should be there. Now what are those 9 orbitals? So we know number of orbitals in any shell is equal to n square in the shell number of principal quantum number. So number of orbitals in n is equal to 3 is 3 into 3, that is 9 orbitals. Now what are those orbitals? See here n is equal to 3 means it should have the subshells like n is equal to 3 means assume the quantum number will be 0, 1, 2, 3. So altogether 3. 0 should also be counted. Okay, here 0 doesn't mean that nil. 0 is also a value. So when n is equal to 3, then n will have 3 values 0, 1, 2. 0 means S subshell, 1 means P subshell, 2 means D subshell. Now 3 S is one orbital. 3s itself is one orbital. Next, n is equal to 3, n is equal to 1. Means 3p. This is only one orbital. So we can write 1 3s orbital. In that way, here we have n is equal to 3, n is equal to 1. 3p. In p subshell we have 3 orbitals. So we can write 3p orbitals. Now n is equal to 3, l is equal to 2. D. 2 means D subshell. D subshell contains 5 orbitals. So 3d 5 orbitals. So we can write 5 3d orbitals. Now if we add all these, 1 plus 3 4, 4 plus 5 9. So altogether we have 9 orbitals. So if it is 1 mark question, marking scheme will be like half plus half. How many orbitals are they? Using the formula we are calculating 9 orbitals. That carries half mark. Next, what are they? Then we have to go for this calculation. n is equal to 3 means azimuthal quantum number should have 3 values. And those 3 values are 0. 0 means S subshell. 1 means P subshell. 2 means D subshell. So S subshell will have always only 1 orbital. P subshell will have always 3 orbitals. D subshell will have always 5 orbitals. So that way if we count, we will get 9 orbitals. This is one simple question based on the relationship between principal quantum number and the magnetic quantum number. Here principal quantum number speaks about the shells Magnetic quantum number speaks about the orbitals. Azimuthal quantum number L speaks about the subshell. Fine. Now we will move to other question. That is, using S, P, D and F notations, describe the following. This is one of the NCERT questions. Using S, P, D and F notations, describe the following. In that, N value, L value. N value means principal quantum number. L value means azimuthal quantum number. These two quantum numbers are given and you need to describe by adding together N and L. Means which subshell is present in which main shell. This is the point. On this point, question can be asked this way. Using S, P, D and F. These are subshells. Using S, P, D and F, describe the following. Number 1. N is equal to 1. L is equal to 0. Number 2. N is equal to 2. L is equal to 1. Number 3. N is equal to 4. L is equal to 2. Number 4. N is equal to 3. L is equal to 1. Each one carries half mark. Half into 4, 2 marks. So this is the question. We have to describe means which subshell is associated with the main shell 1. So here values are given. Values are azimuthal quantum number. Right? Means subshells. Here 1, 2, 4, 3 represents main shells. 0, 1, 2, 1 represents subshells. Now, in place of these values, if we know the notations, then we can write easily. For L is equal to 0, 0 subshell, we write the notation S, S subshell. 0 subshell means S subshell. First subshell means P subshell. L is equal to 2. Second subshell means D subshell. Next, L is equal to 1 means P subshell. So, for 0 we write S subshell, for 1 P subshell, 2 D subshell, 3 F subshell. This is what you people need to remember. These are the values of azimuthal quantum number and these are the notations. Same thing is written here. Right. Now we have to describe. Means for each principal quantum number we have to write the subshell notation associated. Like N is equal to 1 means 1. L is equal to 0 means S subshell. So 1S we write. So this carries half mark. 1S means in first shell we have S subshell. That is the meaning. Number 2. N is equal to 2. So 2 will write as it is, principal quantum number, and m is equal to 1. That means p sub shell. So for p sub shell 2p we write. This carries half mass. Half plus half, 1 mark over. Now let us see the third one. N is equal to 4 means fourth sub shell. Fourth orbit or the shell lying, that means fourth circular path lying around the nucleus. First, second, third, after that the fourth. Next, n is equal to 4 over n is equal to 2 means d sub shell. We write d, 4d. Next, number 4, n is equal to 3, n is equal to 1, 3p. And these are the solutions. Simple questions. This can be asked for 1 mark, like half mark into 4 times. Half into 4, that is 2 marks question. So in this way the question need to be attended. The only thing is, what are the values, what are their notations. There is no reason. Now we will move to shapes of orbitals. Here we have 4 different types of orbitals. Now let us see what are their relation with subshell. S subshell contains only one orbital in it, that is s orbital. P subshell contains 3 orbitals in it. What are they? How are they represented? That we will see. Next, third type of orbital is d orbitals. They are there in d subshell. So d subshell contains 5 d orbitals in it. Next is f subshell. That contains 7 orbitals in it. So in this way, s, p, d and f subshells contain orbitals and their number is not fixed in each subshell. S subshell only one orbital called s orbital. P subshell contains 3 orbitals. D subshell contains 5 orbitals. F subshell contains 7 orbitals. So here you need to remember one point. Inside the shell we have subshells. Inside the subshell we have subshells called orbitals. Once again, inside the shell we have subshells. Inside the subshells we have orbitals. This is what you need to remember. Now we will move to shapes of orbitals. Shapes of orbitals. As I told you, we have 4 different types of orbitals, and out of these 4 different types of orbitals, 4th type of orbital, F, doesn't have any shape. So our main focus is over s orbital, p orbital and then d orbital. Now, yes children, as I told you, 3 orbitals have specific shapes like s orbitals, p orbitals and d orbitals. F orbitals do not have any shape. Now we will move to s orbital. Shapes of orbitals in that first one is s orbitals. S orbitals have spherical shape. Like circle, right? And we have depending on the principal quantum number, means shell number. First shell will have s orbital in it. Second shell will have s orbital in it. Third shell will have s orbital in it. Now, what are the differences between these s orbitals of different main shells? Like 1s orbital, 2s orbital, 3s orbital, 4s orbital. S orbitals are there in these s subshells. These s subshells are there in these principal quantum numbers. As the principal quantum number increases, the energy possessed by the s orbital of concerned s subshell will be more. Means energy possessed by 2s orbital is greater than 1s. Energy possessed by 3s orbital is greater than 2s. Energy possessed by 4s orbital is greater than 3s. This is what you need to remember. Right. So, shape of s orbital is spherical and it will be like this. And axis we can show because orbital is three-dimensional region. So x, y, z. This is s orbital, right? If we move to 2s orbital, it will be slightly different, and that I will take up little later. Now I will move to p orbital. P orbitals. These p orbitals are present in p subshell. So you can write there are three p orbitals in p subshell. P subshell doesn't contain s orbitals, doesn't contain d orbitals. P subshell will have p orbitals only. Value of p is 1, value of s is 0. Right? Fine. So there are three p orbitals in p subshell. As far as shape is concerned, each p orbital is dumbbell shaped. Each p orbital has dumbbell shape. Now let us see these three p orbitals, how they are indicated. There are three axes, x, y, z. If p orbital is shown, that means dumbbell is shown over x axis, then it is said to be px orbital. If dumbbell is shown over y axis, then it is said to be py orbital. If dumbbell is shown over z axis, then it is said to be pz orbital. Now let us see these three orbitals. This is one dumbbell, right, and axis I will show in this way. This is x-axis, y-axis, z-axis. Since dumbbell is lying over x-axis, therefore it is said to be px orbital. Now I am going to show dumbbell over y-axis. It will be like this. X-axis, Z-axis, and this is Y-axis. And this is nothing but Py orbital. Here, dumbbell is lying over Y-axis. That is why it is said to be Py orbital. Now let us see Pz orbital. So z-axis is vertical axis. So I'll show dumbbell vertically in this way. This is PZ. In this way we have three different orbitals. So shape of P orbital is dumbbell depending on the axis on which this dumbbell is lying. Name is given to that orbital. Like if dumbbell is there over x-axis, it is Px orbital. If dumbbell is there over y-axis, it is Py orbital. If dumbbell is there over z-axis, then it is said to be Pz orbital. That's about the three different p orbitals lying in the p subshell. And this p subshell is there in all the shells except first shell, where n is equal to 1. There p orbitals doesn't exist because first shell doesn't contain p subshell. D subshells. First let me explain, thereafter I will go for drawing the structures. D subshell contains 5 d orbitals in it. First point. Second point, d orbital, each d orbital has its own specific structure. Structure in the sense on which axis that d orbital is shown, or in between which axis the d orbital is shown. Here, each d orbital has double dumbbell shape. So there are 5 d orbitals. So shapes of d orbitals. There are 5 d orbitals in each d subshell. Next, d orbital has double dumbbell shape. They are dxy, dxz, dyz, dx square, y square and dz square. These are the 5 different d orbitals. Now let us see these orbitals one by one. First one is dxy orbital. One thing keep in your mind, children. These notations S, P, D and F should be small letters. So d orbitals, D should not be capital letter. Fine. Come to dxy orbital. First I'll show axis. 3 axes in this way. X-axis, Y-axis, Z-axis. dxy orbital. So in between x and y, what opposite to that? This is dxy orbital, first orbital, right? Now we'll move to second. That is dxz. Again three axes are shown like this. In dxz, dumbbell is shown, one dumbbell is shown over y-axis like this. Right? The other dumbbell quite opposite to that. So this is dxz orbital. This is one dumbbell, this is second. That's why d orbital is said to be double dumbbell structure. Now, third one is dyz orbital. X-axis, y-axis, z-axis. Third one dyz, yz. In between y and z, double one dumbbell, quite opposite to that, the other dumbbell. So third one is dyz, orbital. Now we'll move to fourth type of d orbital, that is dx square y square orbital. Here, one dumbbell we need to show over x-axis, the second dumbbell we need to show over y-axis. So we will show axis first. This is x-axis, y, z-axis. Now on x-axis one dumbbell, next on y-axis, other dumbbell. This is dx square y square orbital. Next we will move to fifth type of d orbital, that is dz square orbital. This looks slightly different when compared to the four different d type of orbitals. Here first let me show the three axes as usual, that is x, y, z. These are the three axes. And the fifth orbital is, as I told you, it is d z square orbital. So z axis is this. Over z axis we will show one dumbbell. And here, instead of dumbbell, what I am going to do is, I will show one circle over x axis like this. This is 3dz square orbital. So in this way, children, we have 5 different types of d orbitals. Once again, s orbital has spherical structure. D orbital has double dumbbell structure or the look. Right? And in the case of s orbitals, as we move from n is equal to 1 to n is equal to 2, 3, 4, 5, etc., the energy possessed by the s orbital increases. Like 3s orbital has less energy than 5s. 5s orbital has less energy than 6s, and so on. Next, when we move to p orbitals, p subshell has 3 different types of orbitals, and those 3 different types of p orbitals are px orbital, py orbital, and pz orbital. And here, px, py, pz. These names are given to p orbitals based on the axis on which the dumbbell of p orbital lies. If the dumbbell p orbital has dumbbell shape, if the dumbbell lies over x-axis, it is px orbital. If it lies over y-axis, then it is said to be py orbital. If dumbbell lies over z-axis, then it is said to be pz orbital. So based on the axis on which the dumbbell, that is p orbital, lies, the name is given like px, py, pz. Now, if we move to d orbitals, d orbital has double dumbbell shape. Right? All these d orbitals, there are 5 d orbitals, and all these 5 d orbitals are located in d section. And those 5 d orbitals are dxy, dxz, dyz, dx square y square, and dz square orbital. Right? And that's about the shapes of d orbitals. Now we move to a small concept, one more concept, that is node or nodal region or nodal surface. It is also called node or nodal surface. In some reference book, nodal region is also given. Now let us see what is meant by node or nodal surface. The region where the chances of finding electron is 0 is called node or nodal region or nodal surface. So the region where chances of finding electrons is 0 means in that region electrons do not exist. That is the meaning. So that region is said to be nodal region or node or nodal surface. In next class we will see these nodal surfaces in the case of s orbitals, p orbitals, etc. Thank you, children.